I will start from the short introduction myself. My name is Viacheslav Katsuba, but you can call me Slava, and I'm Ukrainian Erlanger. Provided last 6 years Erlang software development and consulting services for the different projects, and you can find me in the different social networks. Also, half years ago, a little bit more, I was started writing a blog post, so I'm also available in Medium, and together with the Adolfo Neto and Brujo, we was opening the Erlang podcast, Hello Erlang, where we get the interesting interviews from the Erlang community. And today I want to start discuss Sheldon Erlang library. Basically, a little bit more than half years ago, I was meet with the Brujo Benavides, and we discussed the ideas about the creating rebar plugin. And one of the ideas was create some rebar plugin for the spell checking of the code, basically checking the binaries, documentations, strings, etc., using the abstract syntax tree. So, and he showed me that already existed in the Inaka project Sheldon library, the Erlang spell checker. This spell checker was created by Felipe Ripoll. Basically, this is a first spell checker in the Erlang in the world, what was created for the Inaka projects. You also available to find this guy in the social networks. He also have his own blog post and available on the Twitter. So what is Sheldon? Sheldon is Erlang spell checker. Basically, this is a small Erlang library which can be integrated into any existing project, Erlang project, of course, and or can be run as standalone application. And basically, the main idea of the Sheldon was one of the ideas to do spell checking of the markdowns and the HTML files in the project. Let's quickly take a look how Sheldon works. Here have the internal API for the starting. He has a standalone application like Sheldon Start. For the checking any text, you can put to the API check and put any text. This can be as a binary or the string. Basically, this can be as a one line, as also can be big text data divided by new lines, etc. Now let's try to put, and of course, if all is okay with the text, the Sheldon will be returned okay. Let's take a look how it works when Sheldon try to put, when we try to put to the Sheldon incorrect misspelled word. Sheldon will return a response which is include couple fields. Response like a map and collected fields like bazinza, the funny random text, then misspelled words. We also can see that candidates which are more related to the correcting word, so provided misspelled or misspelled words, candidates for the changing this typo in the text. Of course, provided the line number and the original word. So also Sheldon have configuration side. Basically, he can be configured as from the system config file, or can be configured in real time. Basically, you can generate the map configuration and put it to the check functional call as a next argument. Basically, for this example, we can see that Sheldon doesn't know his own name, basically, and this is name is not applied in the knowing the words. By this reason, we doesn't see any candidates and see that original word Sheldon is have a typo. For the ignoring this word, by example, we can create ignoring use the ignore words configuration, put to the check functional, and as a result, we can see that Sheldon ignored successful this word and returned the atom. Okay. Also, in the Sheldon available configuration using the reg experts, reg expressions, sorry, ignore patterns, basically, where we can put the chars and some regular expressions, and they will be skipped, basically, as we can see in the line 5. Spell check also returned the atom. Okay. Basically, as I mentioned before, the Sheldon was created for the Markdown checking file and the HTML files. By default, a couple adapters where we can put those adapters is simple modules provide some lines and can be created your own without any problems. But by default, Sheldon have the two adapters for the reading of markdowns and HTML. In the ignore blocks, as you see, we put a couple config stuff like close and end blocks of the text, and in the line number 7, we see that those blocks successful ignored. But basically, how the Sheldon is works exactly in the background. Let's start from the first versions and then continue about adapting and speed up work of the Sheldon. Sheldon was having in the previous versions Peter Norvig algorithm and used it for the building language model types and the candidate model and error models, etc. But the main problem was in the generating of the candidates, and let's see what exactly issue we have. Basically, for the correct working of the Peter Norvig algorithm, we need to have of course the input, the word, and also pre-prepared dictionary with the knowing of the words. So basically, this can be some abstract database of the existing words for different languages, by example. So, first of all, we check this word in the existing words and providing words in the dictionary. If we find it, this word, then we will return okay, and this means that word is not need to change it or provided candidates. Then if we doesn't find any suite words in the dictionary, will be applied some abstract generation candidate model, which is divided to the two parts, edit number 1 and edit number 2. Let's see how edit number 1 is working. So basically, edit number 1 divided in the sub 4 points for the generation of the possible candidates. The first point is the latest. Basically, step by step, each char will be deleted from the input word, and this will be applied to this word recursivity, and by this reason will be generated deletes candidates. Then we have the transposses approach, where we try to change chars by indexes in the word, because maybe some chars was put it incorrectly, or something like that. Next point is replaces. Here we include another additional input, like alphabet, let's say English alphabet, for the applying between in the first and next char. In the middle we will be put I'm sorry, not in the middle. We will be replace each char from the alphabetic, and will input this char to these words, and we will apply for the each char in the word and for the each char in the alphabetic the same approach, recursivity. By this reason, will be generated third part of the possible candidates. And the insert basically also have the alphabetic and get the char number 1 and 2, try to insert the chars from the alphabetic into the word between of the first and next char in the middle, and try to apply this also recursivity. But this reason will be generated a lot of possible candidates, and will be returned as a result to the functionality number 1. Then we try to check all these candidates in the if they are have it, and we know these candidates in the existing pre-prepared dictionary. If yes, we return these possible candidates. If not, basically we apply the number to edit, where for the each already generated candidates, we will reapply the same logic, but for already generated possible candidates. But this reason will be created, as you understand, that pretty a lot of possible candidates. But what the issue here? Basically, we doesn't have any big issues with the small words, but if we take a look, by example, for the big words, this is I find it mostly the bigger word in the English, and this word is related to some medical area, and the length of this word is 45 chars. If we will put this char, I mean, that generate the same word, I don't know, with some typos, and pushing to the Peter Norvig algorithm, he will be generated 11,553,868 possible candidates, and will spend it plus minus 8 seconds to generate all of them. Basically, this is not related to the implementation in the Erlang. This is also the same speed and the same issue in the other languages like Golang, C, Python also was finding similar solutions, run it benchmarks, and have the same issue. So basically, Peter Norvig algorithm is working great, but another algorithms work a little bit faster, and by this reason I started thinking about the improving how Sheldon can be improved, and how we can speed up the work of the Sheldon, basically. And of course I start going to the Googling something and try to find other spell checking algorithms and how they work. In the middle, other algorithms have mostly the same benchmarks. They take the algorithm, generate then 2,000 incorrect words, and just run the scripts, and in the middle for the spended less or mostly 2 seconds for the spell checking 2000s incorrect words. If we will do the same for the Peter Norvig algorithm, basically we will need spend more or less 5 hours to the spell checking 2000s incorrect words. I mean the big incorrect words. Okay, one of the algorithms has name as SimSpell. Basically, this is algorithm collected a lot of different other algorithms and started, of course, also from the Peter Norvig algorithm, included some filter bloom algorithm, etc. But what I mentioned that, and I very like this idea, the indexed typos model. Basically, what this means, we have the some word in the dictionary. Let's say this will be a simple text. In the background will be generated the index for this text, this word based on this word, but we will remove one char from this word, and in the next index we will be return previous char and will remove the next one and till end of the word. But this reason in this example will be generated similar indexes like txt, tet, text, and ext. They are linked with the real world and stored in the some caching. Then we can get as an input incorrect word. That yeah, and this word will be also to this word will be also applied indexed model typos model approach, and will be generated as you see the other indexes. If we will compare these two words by example and their indexes, we will can see that the one of the indexes is matched. So by this reason, for this incorrect word, we can told that the text is a great candidate for the providing to the user for the changing of the typos in the text. So basically, after improving and some updating of the logic, I was generated 2000 incorrect words with the length of the 45 chars each of them, and run it for the SimSpell-like algorithm, and basically was spent for the spell checking 1 seconds. Basically, this is was a great. This was a great speed based. Okay, after the improving of this library, we are able right now to integrate this library to the any existing project. And of course, the next idea was created the Sheldon rebar plugin for the checking the source code based on the abstract syntax tree in the Erlang, and the checking us in the documentation and also in the comments and the other Erlang code. Basically, the using of this rebar is pretty simple. You can just put it rebar Sheldon to the project's plugins in the rebar config, and just run it in your project like rebar 3 spell check. And as you see, the output is pretty similar to the for the Dialyzer or the famous library Hunk. As you can see, we have the same funny text from the Sheldon to the keep spirit of the Sheldon library. Here also provided the patch to the file, put it the line, and of course provided type or where exactly this typing, the typos was found, by example, in the binary, in the string, or in the comments, and provided also possible candidates, or can provide information that he didn't find any possible candidates generated. In the end, I want to say that we provided a lot of different useful links for the getting to know a little bit more about the Sheldon, about the rebar plugin. Also provided a couple topics, and of course, the one of the important topics is the Peter Norvig blog post, which also is provided. And thanks, that's it, I suppose.
Hello, thank you for the talk, and thanks for joining. We have a few questions already on the Hoover, so I'm going to read. Does anyone here in the room also wants to ask a question? Right, you want to ask a question? Okay, so I'm going to read the questions for you, right? So the first question here is it possible, that's not the first one, it's changing the order. Okay, sorry. Is it possible to use a Spanish or another dictionary?
Yes, of course. Basically, you are able to configure it as the Sheldon, as the Rebel plugin using your own dictionary. You can put merge couple dictionaries, because Sheldon already have some default English dictionary, but this will be not suited for the or cover all possible points. So you are able to put any words. I suppose the big issue for now is using and spell checking of the Unicodes. We are working on the improvement of this stuff, but with the Unicodes, we have some problems for the spell checking.
Right, thank you. Have another interesting question. Does the algorithm handle word variations? Example given, plural forms, noun cases, verb conjugations?
Basically, you see, this library is still in some development, and still we need improve a lot of stuff, which is related more to the model language, basically, because providing candidates, possible candidates, is not always, in the 100% is correct. So yeah, but for now, I suppose we need to still improve it a little bit.
All right, thank you. I had one question here, but I think was already replied. I mean, maybe we want to check later if it's the right, but was can you put a link in the chat for the Peter Norvig's algorithm? Adolfo put a link there. Maybe it's already the answer. But yeah, I think.
Yeah, sure. I will put all these links. Or you wanted to in the Zoom?
I think the Hoover app would be the best.
Yeah, I will provide all these slides and links.
Okay, thank you. Do you have any more questions here? No? Thank you.
Thanks.